the first step is for us to convert all value into per unit, right? Then that will make our calculations and our setting more convenient. So the first part, we look at ZS. ZS is the impedance of the from the source. So ZS is here, right? ZS is somewhere over here. So ZS is 1 per unit, all right? We take it as 1 per unit because we take the source MVA and KV as the base value. So, and then if we take ZS as 1 per unit because we are taking our base value, the Z base, right? As I mentioned just now, the voltage and the S as our base value. So we can calculate our Z as such, right? This is the equation V equals to S equals to V squared over Z. So I'm just doing the rearrange. I just rearrange the equation and get ZB, the Z base value as this. And then the first conversions to per unit is ZC1. So where is ZC1? ZC1 is over here, right? ZC1 is over here. You are given this value per km. So multiply 2, you have to take this multiply 2, and then this is given to us in complex numbers. So we want to convert this into the magnitude. So you know how to do that. And there is also 5 cables, right? 5 cables. 5 multiply the size, right? This 5 here is 5 cables. So we want to get the per unit for 1 cable on a per cable basis. Therefore, we divide by 5. So you get this value. This is not a per unit. So you divide this by the Z base. So this is the magnitude of the impedance. Multiply the 2 km because you are given in the per km basis. And then you got 5 cables, so you divide by 5 cables, you get this ZC1. This ZC1 converted per unit divided by the base value. And ZR1, you are given in 4% on 20 MVA. So 4% is already a per unit. So you want to get the Z on the 500 MVA basis, right? So 20 MVA is 4%. And then 500 MVA is how many percent? You want to convert it on a 500 MVA basis. So by doing the simple rearrangement, and then you get 1 per unit. And then you go on by doing the conversions for this C2 and C3. So this is a 1 cable. So 1 cable only. So because 1 multiply something. And this is the impedance on a per kilometer basis. And the length is 1 kilometer. Therefore, this multiply 1 and take the magnitude, divide by 1 to get ZC2 and ZC3 as such. And then take this, divide by the Z base, you get this value. All right. So this is fairly straightforward, right? Fairly straightforward. We are just converting all the impedances into per unit first. Right. And in step 2, we want to determine the fault current at each of the load bus. Okay, fault current at each of the load bus. Why we want to determine fault current? Because we need to have fault current level. Then only we can determine what is the setting for our relay. All right. So in the next video, we will look at how we are going to perform fault current analysis.